Okay, so this is our last tutorial, and this is on the settlement, and you have one question in your final exam. I told you last time, it is you have to use the week 10 content. Okay, that question is very similar to your one of the questions in the tutorial. So only the numbers are different, otherwise the question is the same. So you should be able to do it if you do the questions in the tutorial here. Okay, so let's start with the first question. We have only 3 questions, and it is covering whole week 10 content. So it's a good revision for the week 10. In the first question, they are saying a clay has properties. So they have given you the properties of clay, CC and CR, and determine the final void ratio. They are asking you to find the final void ratio after the settlement. That means the final E, isn't it? For the following situation. So they have given us few situations. The first one is they are saying, so when we find the final void ratio, you know, when settling, it's the soil is settling like this, isn't it? So this value here, so this graph, in this graph, x-axis you have log effective stress, and the other axis you have the E, isn't it? So if you look at this one, this is the corresponding value for the sigma dash P, and the other values can be anywhere, we don't know. For example, if you look at the first one, they say initial value is 50 and E is 1.2. This value P sigma PC is 100. So this value is 100 kilopascals and final value is 90. So you know this initial value. E naught is known. This is given. And you need to find the E final. So E final is the initial void ratio plus whatever the change, isn't it? So this change is happening when you go from here to here. Do you agree with me?
Yep.
So where is this sigma 0 dash? It is somewhere here, isn't it? So this is sigma 0 dash, and final value according to the first one, it is here 90. So when you come from here to here, your void ratio is decreasing. Do you see that? It is decreasing by this amount, isn't it? Am I right? Can we find that amount? This one, this length, can we find that? We can. Why is that? We know these gradients are given to you. Slopes, this CC and CR is given. So CC is this one, isn't it? CR is this. So CR is 0.05, CC is 0.4. So if you know the gradient, this is the tan theta. Tan theta is the opposite over the adjacent. So if you write here 0.05 is equals to opposite, which is delta E, and divided by the adjacent. Adjacent is this one, isn't it? So adjacent is log minus log. Have I done it right? Do you agree with me? So if you, in this equation, you know this one, you know this one, you only don't know this. So you can find delta E, and when you find the delta E, and if you put this one here, actually this is minus because void ratio is decreasing, isn't it? When you go from here to here, void ratio decreases. So if you minus the delta E from the initial value, you get the final value. Is that make sense? Or not? Is it clear or not?
Yeah, I think that makes sense.
So can you find me that? How can I do undo? I think I can't. Okay, so what did I write? Delta E is equals to, sorry, not delta E. 0.05 is equals to delta E divided by log sigma F final value minus the initial value. So I can write like this. Do you agree with me? Can we write like this? Log something minus log something, you can write it as a division, isn't it? So delta E is equals to 0.05 times log 90 divided by 50. So you can find the delta E. So delta E is, what do we get for delta E? Were you able to find the delta E? So that is this amount, delta E. So you can find the final E is equals to initial E minus the delta E. So you can find the final E. When you find the final E, let me know in kilopascals. Yeah, this doesn't have, void ratio is a ratio, so it doesn't have any units. Do you get this? You get 1.1872. Do you get this, or are you getting a different value?
Yeah, I got 1.1873. Yeah, I got that.
Okay, yeah. How about you, Karen? Now
Yeah,
you,
I got that.
okay, that's good. Let's do the next one. Here now, what is happening here? You need to think, I'll give you some time. So it's like this now, okay? So here, this one is 0.05 and this one is 0.4. And your axes are log and E. And this value is given to you, which is 100 kilopascals P. And you have to take the log, okay? I just write this one. So where is the initial and where is the final? Where is the initial? Initially somewhere here. Am I right?
Yeah.
And
And the
finally
past.
somewhere here. It's not hard. So you need to find the change in the E. So initial to final. So change in the E is this much, delta E. Am I right? So you can't find it in one go. So what you do, you find this one separately, delta E1, and you find this one separately, delta E2. Am I right? So your E final is equals to E initial minus delta E1 minus delta E2, isn't it? Can you find me this? Does that make sense? How do we write delta E1? So delta E1 is equals to E1 is 0.05 times log 100 divided by 50. Is that right? And delta E2 is what?
It's CC value.
Yes, 0.4 log. Then this one will be 190 divided by 100. Find these two and then minus those two from the 1.2.
I got 1.07344.
Yeah, that's right. How about you, Caroline? Do you get something close?
1 second, I'm still going.
Yeah.
Yeah, I got that.
Okay, that's good. Now let's do the next one. Okay, so this one is easier than the before. So this value is 50 and this value is 90 and initial value also 50. So it's going from here to here. So it's easy. This is our delta E. So delta E is equals to, here we have 0.4 gradient, 0.4 times log 90 divided by 50. And EF is equals to 1.2 minus delta E. We should get, what do you get?
I got 1.09789.
Yeah, that's good. So Caroline, do you get the same?
Yeah, I get that.
Okay, that's good. Two more. This one. Okay, now you have to think and do this, okay? What is happening here? Void ratio is, what is happening to the void ratio? Increasing or decreasing?
Increasing?
Increasing. So your initial value is 50. Initial is 50. Now it is going to 30. So it's going up. It's going up. So this value is 1.2. So you need to add this delta E. You need to add the delta E. So you adding the delta E. Finding the delta is in the same way. There is nothing difference there. So delta E is equals to 0.05 log 50 over 30. So you find this and you are adding that to the initial value to find the final value. So EF, what do we get?
one. I got 1.211.
Yeah,
Yeah, I got the same as that.
last one. Initial value, it's the same, isn't it? No. 50 and 30, and this one is 50. Oh, it's very similar. It is same, isn't it? It's same.
It's got the sigma p's different.
Sigma p different, but it's
Yeah, other than
doesn't make any difference, isn't it?
yeah,
You get
be the
this.
same here.
That's good. Okay, any question up to here? Okay, this is the important question. Can we did one of these questions on Monday? Caroline, were you able to go through the recording? You were not in the class, right?
Yeah, I only had a quick look at it really, but I'll figure it out, I'm sure.
Okay, so yeah, let's see here. Okay, I'll explain. Okay, now when settlement, we need to find when you consider the settlement and consolidation questions, there are two things to answer. One is how much settlement or how much the soil is consolidating. That means how much volume changes, how much it is going down. And the next thing is how long it will take to take for the consolidation or settlement. So here last week also we discussed how we can find the settlement and how fast it is happening using two equations. Now here we are doing the same thing in the settlement question. Settlement is mostly related to the consolidation. So due to the consolidation, soil settle. So when you're finding the settlement in a different way. Now you can find the settlement using the last week content, but here we learned in week 10 a different method to find the settlement. So finding the settlement, to find the settlement, there are three equations. So first equation is this one. The second equation is this one. Third equation is this one. So to select the right equation, you should know where is your initial sigma and the final sigma. This sigma is your sigma p, where you have the change from virgin to unloading state. So this value we call the sigma p. So sigma p value, depending on where your final and initial values are, you have to select the right equation. For example, if your initial and final both are in this side, so this is your initial and this is your final. If you have the effective stresses like this, which equation we should use, Sean?
The first one.
The first one, yes, we are using the first one when you both are in this way. So if both are in this side, sigma 0 1 dash and sigma final dash, you use this one. So this is the second one. So this is the second. Third one you use when you have in the two sides. So your sigma naught is this side and sigma f is this side. If you have like that, you are using the third equation. So it is very easy. You're just substituting the values in the equation. But the important thing is finding the right equation depending on where is your sigma naught and sigma f. Is that clear, Caroline?
Yeah, that makes sense.
Okay, so now let's see how we can find that. So in these equations, mostly in your questions, these values, most of the values will be given to you. So this will be given to you. This, if it is not given to you, the initial void ratio from the first week content, you can find the void ratio. You can use those equations to find the void ratio. And this final value, again, you can find it from, I think, week 5 content. Stress increase. Can you remember we discussed in one of the modules stress increase? So you can find the stress increase. Initial stress also you can find by the equations that we have used. We are going to use it. So it is revising the previous week's content as well. So this HI is the height of the thickness of your soil layer. So this, if you know these values, And the next one is this P value. Yeah, if you know these 1, 2, 3, 4, 5 things, you just substitute and you're finding the values. And 6, sorry, this CC and CR both, you need to know those as well. So if you know that, you just substitute the values and you are finding the settlement. So when you have many layers, you find the settlement to different layers separately, and you add all the settlements together to find the total settlement of the soil. Okay, now let's see how to do this question. They are saying the embankment is built on a site where the soil profile contains 3 meters of clay. So we have a 3 meters. We have a 3 meters clay. Overlying rigid impermeable rock. So we have a impermeable rock here. And the water table is 0.5 meters below the soil surface. So we have the water table somewhere here, and that is 0.5 meters below the surface. The embankment applies a pressure of 75 to a point at the mid depth. So this 75 is not this, is that this one? Is it this one, or else it is it the stress at the middle? What they say? It is the stress at this point, isn't it? Am I right? It is applying a 75 kilopascals because of whatever the stress here will be transferred, and it is applying 75 kilonewtons up here. The clay layer below the center of the embankment. If the clay is saturated above the water table, so it's not sand. So even though your water table is below, the upper layer, this one, from here the soil is saturated. So you don't have dry soil. Soil all up to from here to here is saturated. If you have sand can't, like, sand will drain. It can't keep water. So if it is drained up to the water table, but they are saying as this is clay is saturated. So this 0.5 meters also saturated. We have saturated clay. Calculate the settlement of the center of the embankment using the one-dimensional method. So you can do this question from week 9 content, but they're asking you to use the one-dimensional method and single soil. So you have only single layer. So just one time calculation, isn't it? Am I right? Okay, now let's see what are the other things that they have given. So they have given us the initial void ratio. So that's good. This one, the initial EIO, E0 is given to you. Specific gravity, G is given to you, GS. Over consolidation ratio. So if you can remember from the theory, that is this one. So over consolidation ratio is given to you. CC is given to you, CR is given to you. So these ones are given to you. So first thing is for us to find the right equation. To find the correct equation, we need to find this one, the initial value and the final values. Can you think of finding this? How do we find the initial? I'll do the initial. How do we find the initial? Initial value is equals to initial effective. Initial effective is equals to initial total stress minus the U. Am I right? So this you already know. We have used that for many times. So let's find these two separately. So initial total stress. Now I'm looking at this point. If I'm looking at this point, the total initial stress will be what? Gamma saturated times the height, isn't it? The height will be 1.5. So that will be gamma saturated. We don't know. We need to find the gamma saturated. So what is gamma saturated? From the week 1 equations, gamma saturated is equals to GS plus E initial divided by 1 plus E initial gamma W, isn't it? That is from the week 1. So when you put those values, 2.6 plus E naught is 0.8 divided by 1.8 times 9.81. So we can find this. What do we get for that?
$18.53
Yes,
times 1.5. Oh, sorry.
18.53. Yeah, kilonewton per meter squared. How about you, Caroline? Do you get the same?
Yeah, I get that.
Okay, so let's put that value 18.53 times 1.5. So we can find the sigma naught, which is equals to 27.795 kilonewtons per meter square, meter cube, meter squared, or pascals, kilopascals. Okay, so do you get the same?
Yep.
How do you find the U? U is easy. U is whatever the water height. Water height is 1 meter, right? 1 meter times water height times the gamma W. Gamma W is 9.8. So this is 9.81 kilopascals or kilonewtons per meter squared. So we can find this value, which is equals to 27.795 minus 9.81. So we get initial value as
17.985.
17.985 kilopascals. Oh, yeah. Okay, now we are done with that. So this is found. Oh. This is found. That's good. Now the second one, last final value. How do we find that final value? Final value. We do the same thing, isn't it? We do the same thing for the final value. I'll take it to the next page. In the final value, what is that? That 75, this 75. So due to the embankment, the pressure at the stress increase at the middle point. 75 kilonewton stress is increased there, isn't it? Am I right? So final value is easy to find. So you have initial value of 17.985. So if you add this stress increase to that one, this is the stress increase due to the embankment. So if you add that to 17.985, you get the final value. It's that easy. Isn't it easy? So what is your final value? Final effective value. Or if you add to 17, it will be effective. If you add to this one, it will be the total. So effective will be 17.985 plus 75 kilonewtons or kilopascals. So final 92.985, isn't it? Kilopascals. Okay. Now you know the initial and the final. We need one more, because we need to find out whether these two values are, where are they compared to this sigma dash P. So we need the sigma dash P to find out whether the 2 points are in the left-hand side, right-hand side, or in the two sides. So how do we find the sigma P? You use this one here. Use this one here, and you can find the sigma P. So in this equation, ORC is given to you 4. And sigma, if you consider the initial value, this one is 17.985. 985. So what will be your sigma dash p? That will be 4 times 17.985. So what do we get? We get 71.94 kilopascals. Now looking at these three values, I'm going to write everything in the next one, otherwise it will be too many things. Okay, so this value is 71.94 and this value was 72 point something. 92.985 and the initial value was 17.985. So tell me which equation we should use.
You'd have to use that last one.
Third one, yes.
Yeah.
So you use the third equation, just substitute the values. So I'll bring that equations here. Well, let's copy this. Okay, so let's substitute the values in the third equation. So S settlement is equals to CR. CR is given to us. So CR is 0.035. 0.035 divided by 1 plus the void ratio also given to us, which is 0.8. 0.8. And we have log P value. Sigma P 71.94 divided by sigma O 17.985 and H is 3 meters, isn't it? Plus CC is given to us, which is 0.21 divided by 1 plus 0.8 log final value 92.985 divided by the P value 71.94 times 3. So you put the numbers and you find the settlement in meters.
So because the clay layer is above impermeable rock, is that why we're using H full depth, whereas last lesson we used
Yes,
half?
yes, yeah.
It's training all the way through.
Yes.
Okay.
When you find it, let me know, okay? I have to check one thing. So shown here, your H is not because of the impermeable layer. H is always the thickness of that particular layer. So here it doesn't matter whether you have a whether you have an impermeable layer or a permeable layer, whether you have sand or a rock, it doesn't matter. H is your thickness. H is not, yeah. So
I think it's when, yeah, I think we took that one before. So I'll do this, the soil layer, not the final equation. Yeah, so it's always the full layer. Well, I got 0.07412.
for which one?
Yeah, I got that too.
For that equation S for
Settlement?
settlement.
Oh, okay, let me see.
0.07.
0.74.
74125.
Yeah, that's right. That's right.
So that's the settlement.
Yes, that is the settlement. So your H is, even though it is a permeable layer or impermeable layer, this is the height of the thickness. So when you, if you have many layers, still your height will be like, you have to find the settlement for different layers separately, and you add all the settlements and you get the full total settlement. Okay, so this question is, as I have mentioned, this is important for your final exam. Okay, now let's do the next question. Okay, so this one is week 8 and 10 together. Okay, so week 8, you know how to find. Can you remember in week 8, you found the stress increase in different points? If you have a rectangular something on the soil, and if you have a distributed load in this on this one rectangular, in the rectangular shape, you know how to find the stress increase at a point. So for example, if you want to find for a middle point, what you do, you divide this into 4 equal, this is week 8, isn't it? So 4 equal what we call rectangles, and you just consider one at a time, and you find this, and then you times by 4 to find the total stress increase. So can you remember how to find the total stress increase when you have distributed load? We use this. You remember that?
I remember doing it.
Okay, so let's see whether we can do this question. Okay, so let's first understand the question. So we have a 10-meter wide road is to be constructed across a site where the soil profile consists of 3 meters sand. Okay, so we have a 10-meter wide road. So this is 10 meters. And we have a sand layer of 3 meters thick. Then they are saying, and we have a peat layer. This is sand, and this is peat. And this layer is 1 meter of peat layer. Yes. And over the deep sand deposit. So you have then a deep sand deposit. The water table is 1 meter below the soil surface. So they are saying water table is somewhere here. This is 1 meter. 1 meter below this. The road pavement applies a uniform stress of. So this stress is, road is applying a stress now. It is not the stress increase. This is the total stress applied on the soil. So this one is 20 kilopascals. Okay, in the previous one, they have given you the stress increase, so you didn't have to find it. Now in this case, they have not given you the stress increase. They have given you the total stress applied on top of the soil. The peat is slightly over consolidated. So this is over consolidated, and they are saying OCR is 1.25. So we know what is OPR. This is the OPR. So OPR is given to you. Has a uniform void ratio. Again, this one has a uniform void ratio of 2.0. Recompression index CR is given 0.2, compression index CC is given 1, and specific gravity is given GS is given 2.5. The sand can assume to be incompressible, and dry and saturated unit weights are given to you. Okay, so for the sand, we know two things. We know the gamma dry is 17 kilopascals and gamma saturated is 20 kilopascals. So this is for the sand, and rest of the things, all of these things are for the peat. Okay, now let's see what they're asking you to find. Calculate the settlement beneath the center of the center and beneath the edge of the road. So you have the road. Road is 10-meter width, but it is how long, guys? It's infinite, isn't it? Road is long, so it is infinite. So one side is 10 meters, the other side is infinite. And they are asking you to find the stress increase at 2 points. One is at the here, and also one is at the middle here. So just put two numbers here. So A and B. They're asking you to find at A and B the settlement. Settlement at A and settlement at B. How do we find it? First, find the settlement at A. How do we find the settlement at A? We first need to select the right equation from the three equations. To find the right equation, we need to know three things. We need to know initial value, we need to know the final value, and we need to know the P. Okay, so can you find me these things? At least finally, so final, maybe leave it to me, we'll do together. Can you find these two? In the same way that you did before. So what is the sigma naught? How do we find this? What else we have on top of this?
You have the sand on top of it.
Yes, so start with the sand. At up to here, sand is what? Dry or saturated?
Dry.
This 1 meter. 1 meter is dry. So dry, sigma dry times 1 meter, isn't it? So 1 times 17. Do you agree?
Yep, and 2 times 20.
2 times 20.
Yep, and then point A is halfway or in the middle of the layer.
Yes.
So it's half a meter.
Yes, so that is 0.5 times.
Do they give us P?
They haven't given you this one. So gamma saturated, sigma, gamma saturated for the peat is not given.
So you use that equation we used in the last one.
You use the equation, that's right. So use the equation, gamma sat is equals to GS plus E naught divided by 1 plus E naught times gamma W. Just put the numbers in the equation and find this and substitute that one here. So what do you get?
I got 16.35 for the gamma saturated.
You sure?
I got 14.7.
Yeah, it is 14.75.
Oh, maybe I've done something weird.
Oh, 14.715.
14.71.
Oh, yeah, I typed it wrong.
Okay, so you put that one over here and find me the sigma 0 dash. No, sigma c. This is not sigma 0 dash. This is not the effective value. We need to find it. This is your total. So this is your total.
So that's 64.35.
Yes. So this is 64.35 kilopascals. That is the total. So you need to find the U, and the difference between these two will be your effective value. So U is what? How much depth you have water up to A?
It's going to be 2.5. Is that right?
2.5 times 9.81. So that is equals to 24.525. So you minus these two so that you can get sigma 0 dash effective value. So
39.8.
39.8 kilopascals. Okay, initial value found. That's good. Okay, now you can easily find this because they have given you the OCR. So OCR is this one. This is the one that you found now. This is given. So how do we find this? What is that?
Just what we just found times 1.25.
Yes. So this value is 49. Is that right? 49.79. Is that right? 39.8 times 1.25, right?
I got 49.75.
Okay, that's
I
fine.
must have done some rounding somewhere.
No, that's fine. It's okay. All right. So these two found. Now we need the week 8 content for finding this one final value. Okay. So now let's see how to find the final value. So how to find the final value? Just end the show. Okay. We need this chart. So I'm taking this to the next slide. Otherwise, we don't have enough space. Okay, so now what do we have? We have a road. So our road is like this. It is too long. This is the only distance that we know, 10 meters. This side is infinite, isn't it? So we need to find at a corner. So first at a corner, this is for B. And if you want to find at the middle, they're asking you to find at the middle and also at the corner. So if you want to find at the corner, at the middle, that will be this one. So this is your A. So let's find for the A first. A or B, it's up to you. To use this one, we need two things, N and M. N and M are what? One side divided by the Z, isn't it? Z is the height. So Z is this height from this layer to this layer. Do you remember the week 8 thing? So if you have something here, Z is measured like this. So this is Z, and N and the M are the two length and the width. So this is H, and I just take two values. So you can write these two like this. It's okay to have M and N, and M and N can be like, you can interchange it. N can be written as L over Z, and M can be written as H over Z. So do you remember now? So your Z is what? Z from the top to this point A, that will be, A is at the middle of this meter, so half a meter, 3.5 meters. So Z is 3.5 meters. And L is, one is infinite, the other one is 10. So you can write infinite divided by 3.5 and 10 divided by 3.5. So infinite divided by anything is an infinite. So this one is infinite. So this is infinite. And the other one is 10 divided by 3.5, 2.857. So M is, one of them is 2.57 and the other one is infinite. So you look at this chart now. So you have infinite here. And you have the other one, M, in the other side, which is 2.85, 2.8. So this is 2. This is 2. So somewhere here, am I right?
Yep, I agree with that.
So when you draw a line, .25 or something. No, not 5. This is 2, 0.23, 0.24 something, 2.45. Do you agree?
Yep.
So this one is 0.245 or something close to that. So if you know this, how do you find, can you remember how to find the stress increase? Stress increase is equals to 0.2545 times the value 20, isn't it?
Sorry, where'd the 20 come from? You know, you got the
20 is this
3
20,
before.
20, this 20, the embankment, the pressure at the embankment. Not the embankment, it's road. The pressure from the road. Uniform
Okay.
stress. Yeah. So that 20
It's
times
given.
this one, it's given, yes. So you can find the stress increase, which is 9.72 kilopascals. So this is the increase. You know the initial and you know the increase. So final will be the initial value plus the stress increase, isn't it? In the previous question, the stress increase was given. But here you are finding the stress increase. So stress in,
It's not 9, not going to be 9.
what did you get?
4.9.
0.245 times 20.
Yeah, 4.9. Is that right?
I didn't check actually. If you get something else, that should be correct. I'll have a look. So Caroline, what did you get? Yeah, I'll check. So 0.245 times 20. Yes, 4.9. You are right. 4.9. Yeah.
Because
Kilopascal.
times a half is going to be 10. So yeah. Yep.
And then we do, we add that and we get 39.8 something we got plus 4.9. So the stress that will be plus 39.8, which is equals to 44.7 kilopascals. That's good. Okay, so we know the final and we know the initial. And we know the P. So initial value, whether you are considering A or B, is it different or not? Can you tell me these two values that we found, will there be different whether we consider the point A or B? This value here and this value here, they don't change, okay? So they are the same, even though when you consider B or A, these values are the same because those values are when you don't have the road. initial value, and you use that initial value and the OCR to find the P. So those two values doesn't like, that is before you have the road. So it doesn't matter when you don't have the road, B and A are similar points, isn't it? So these two values will be the same for A and B. Now to find the stress increased, it is different. So this is for the B, but you need to find for A separately. So this is for the B. This is right. So you can use this and you can now find the settlement at B. How do you find the settlement at B? You first need to draw and find out where are these points. So this value we found, that value was 49.75. And our initial value, we know that we have initial value of 39.8 somewhere here. And our final value is 44.7. So which equation we need to use?
The first one.
First equation. You use the first equation and you find the settlement using this. So can you find me the settlement at B? So Caroline, are you okay? Because you were not in the class, but if, as you did the previous one, this should be easy as well. Do you guys need the equation? Yeah, this is the equation. Okay, so CR divided by 1 plus E log the final divided by the initial times the height of the, now how many layers we have? How many layers are settling now? Do we consider the sand, the settlement of the sand? Is that just one layer or many layers?
I feel like it's a trick question, but is it just the peak plan?
It's just the peak. One, why is that? Sand is, we don't consider, sand is settling. Sand has the initial settlement, that elastic settlement only. It's very less. So sand is not consolidating, only clay. Like when you have sand, you don't have to consider the consolidation of the sand. So you don't consider the sand layers, you only consider the peak. The settlement is only happening at the peak. Sand has a very low elastic settlement and we don't use it for the calculation.
It just says that the sand can be assumed to be incompressible.
Yes, it's, you can, yeah.
So, yeah. But do we always assume that? Or do we have
Yes,
to,
always
okay.
for the sand, we don't, yeah. Yeah, it says assume sand is incompressible, yes.
So the equation was log final over the initial, is that right?
Yes, final, yeah, final over the initial times the height of the peak layer.
Thank you.
Yeah, here you don't have, like, you know, two surfaces are permeable, sand permeable, but you are not dividing by 2. You just use the height. That for something else, okay? Dividing by 2 is for the when you use the previous week 9 equations to calculate it. Here you are not using that. H is always the height. Okay, so when you put the numbers here, what do we get? The values that I get is different because they have done something error, no? Here. 4.9 you got, but they have 9 point something, so it's in the solutions. What do we get for SI?
I get a really small number, 0.0029. Sounds too small.
Let me put the numbers in the equation and see. CR divided by 1 point. CR is 0.2. 0.2 divided by 1 plus 2 is 3. Is that right? This is 3.
Yeah,
Log.
sorry. Log 44.7 over 39.8. I got 0.00336. Sorry.
Okay.
I
Then
got the same as that, Sean.
what's that?
I get that as well.
Yeah, good.
What was that number?
0.00336.
Yeah, the first time I only used 44, not 44.7.
Now that should be okay. Meters, this is in meters. So it should be fine. Okay, so we have found for the B. Can you find for the A? So what is the only difference when we are finding for A? Now you are finding for A. So you have infinite. So you need to find for this point. One side is infinite, and the other side is was 10. Now to find the stress increase at the middle of this one, you can use that chart only for finding the corner, isn't it? So you have to divide this to 4 corners. Am I right? For rectangles. So stress increase you can find using this equation. That is right. So this is whatever the 20 times whatever you find here, and total stress increase will be this times 20, this times 4. Why is that? This is the stress increase for one small rectangle where you have the point at the corner. Point always need to be at the corner. So this is for one rectangle and you have 4 rectangles. So this will be 4 times this. Now, when you are finding this one, what is your N and the M here? 1 is always infinite because one side is infinite. You divide infinite by 4 or whatever the number, it will be again infinite. But M is what in this case? 5 divided by 3.5. Am I right? Is that right? So do you remember or not? This is it. Now you need the chart again. So I'll bring the chart again here. Okay, so let's see what is the point now. This is all infinite, that's fine. And M is 1.43, so 1.43. No, it is different. Yes, 1.43. So 1.43, this is 1.543 somewhere here. Do you agree with me? Is that somewhere here?
Yeah.
Yeah.
All right. Maybe 0.23. This can be different, okay? So don't worry if you get different values, as long as you can show these values, that should be fine. So let's take this 0.23. Not 23, 22. 226 or 225 or something, isn't it? 225. Do you agree with this?
Yeah.
Okay, now let's put this value over here and you find it. So 0.225 times 20 times 4. So this is the stress increase. So stress increase is 20 times 0.22 225 times 4.
18.
Is 18, yes. So this is 18. So stress increase is 18. So the final stress is, initial it was 39.8. 39.8 plus 18. So 39 plus 39.8. So this is 57.8 kilopascals. Now, what we have, what do we need to do now? Which equation to be used?
You'd have to use the last equation because over both.
Yes, we need to use the last equation because it is two sides, isn't it? So our initial value, so if I draw the graph now, initial value is 39 point something, 39.8, 39.8, and the final value is 57.8, and the middle value is 44.7. No, what's that? 49.75. So this is 49.75, 57.8. So you have the 2 points, initial and the final, in both sides when you compare with the sigma p. So you need to use the third equation. Use the third equation and find the settlements. That's it. You need this equation. This is the equation. CR is given, E is 2. You know everything, the thickness and everything, just substitute and you can find the S. So when you find this, let me know. Are you working on this?
Yeah. I get another small number.
Yeah, that's fine. It is 0.028.
28.
Yes, that's right. 29 millimeters, right?
28 millimeters. I think.
Yeah, that's fine. Yes. So this will be 28 millimeters. How about you, Caroline?
So it calculates it in meters, and you just give the answer in millimeters.
It's, yeah, if it is too small, if you want to make it to millimeters, that's fine. So as long as you give the units, you can make it in centimeters, meters, millimeters, whatever the one that you want.
Yeah, I got that.
But when you put the numbers in the equation, always you get a meter value, but you can express it as a millimeter if you want to. It doesn't matter if you keep in meter, you still get the full marks. It's okay. Okay, that's good. So both of you got the same answer. That's right. That's good. So these are the 3 questions, and you have one question in the final exam, which is similar to this. It's again a part of the question. So you have to practice questions. You have only 2 hours, right? I have to check that. I think you have, yeah, I'll let you know. I will make an announcement with all the exam information, which date, when to open and when to submit and everything. And you need some graph papers. I will send the graph papers and the response booklet as in an announcement, so you can print it and keep it with you before the test, because there are some graphs to plot as well. So you need the graph papers, and also keep that important information document also with you, so that you have everything handy to answer the questions. Okay, so any question?
Yeah, I was just having a look at the final exam tab, and there's a sample final exam. So that's just something for us to work through, is it?
Yes, that sample exam one, I just sent it to you today in an announcement as well, I think.
Okay.
That one, I wanted to show you how the exam papers, actually exam questions are. I told you that day you have only 4 questions. So in this one also you can see the 4 questions. This is a past paper in 2010 in the university second year. Let us open that. Okay, so it is 2 hours and 4 questions, and 25 marks for each question, but each question has small sub questions. So they have different marks. So I told you the topics, important topics that day, right? So your questions will be on those topics. This may be a bit different, but the questions are like this. So you have 4 questions, but in every question you have sub questions like this. And here, if you go to the question 4, yes. So in the question 4, again, you have something similar to this, like we did today. So last part of the question number 4, you have a table like this, and you will be doing the questions very similar to what we have done in the tutorial questions. If you do all the tutorial questions by yourself without looking at the solutions, I think it's not hard. The final exam is very similar to the tutorial questions. Even this question, see, this is similar to what we have just did, isn't it? So it's not hard if you do all the questions in the tutorials. Yeah, it's very similar. You have different ones, but like, it's your exam paper also very similar, and different people get different questions, I think, for soil. Yes, because you don't have a Viva Voce, so you have, you have different people will get different questions. Very similar, but the numbers and the things are different.
So is there solutions for this exam paper? Or?
I will try to find the solutions, or otherwise I will work it out and will maybe put in views.
Okay.
So total of 100 marks, but it is, I think, 40 or 50%. I will give you all the information, whether I don't think there is a threshold, but I'll confirm and date and the time and everything. And also I will send the response booklet. Any other questions? No questions? Okay, if you don't have any questions, I will wish you all the best for the final exam. I will see Caroline tomorrow for payment, but Sean, we don't have a Viva Voice. So good luck with the final exam. And if you need any help or if you need any clarifications, just drop an email. If you want to set a Zoom meeting, we can do that as well.
Okay, thanks very much for that, Apika.
Okay, so we'll wind up the class, and again, good luck.
Thank you. See you, Apika.
Thank you.
Okay,
Bye.
Yeah.